Good day everyone, again my name is Dolo S, Tokpah. I'm glad again to be with you. Normally I have my YouTube channel where I contribute to you new methods in solving mathematics problems and some of those challenging problems that mathematicians have solved over time. I innovate, create new approaches that will help ease your mathematics skills, that indeed will make your mathematics skills to be more efficient. Like I said, see on the board, we got mathematics tutorial. This mathematics tutorial, and it is me, Dolo S, Tokpah YouTube channel. Today we will be solving problem in system of equation in two variables. Some mathematicians will call it linear equation in two variables. Some will also say 2 by 2 linear equation, but the overall name is system of equation in two variables. So we will be using a method that will help you out, and don't forget to subscribe to my YouTube channel so that every Saturday we will give you new approaches that will help to improve your mastery. Like I said, mathematics innovation, and we are here innovating, doing all our possible best to give you the best you need. And don't forget to also comment, because your comment will also help to strengthen us and to see how best we can add a more future that will help to improve your math skills. Like I said, this is the question. The question here says, by using Gaussian elimination without back substitution, find the solution set of, and this is the solution, this is the problem, 5x minus 4y equals 6, and negative 3x plus 3y equals negative 3. So we are asked to find the solution set of this problem by using back substitution. I have done a research on a lot of websites, go through a lot of mathematics books, and what I've observed is the Gaussian elimination is being used and reach at a point wherein they will use the by-phase substitution or the back substitution. Whenever they solve for y in the two variable equation, they're going to take it right back to use one of the equations to find the other of the variable. And it's a good method anyway, but I was able to innovate, create an approach that we will not substitute for anything. We're going to use the direct Gaussian elimination to get the values of the variables within the problem. So my simulations, I thought it wise to have introduced this to the world, and it is called the Gaussian-Dolo Elimination, similar to the Gaussian-Dolo Elimination. So thank you, and let's keep it going. Method, the Gaussian-Dolo Elimination is the method I'm going to be using now to solve this problem. And you can also use this method in any given problem that you are asked to find two variables, like any linear equation in two variables or system of equation in two variables. So you can use this method. I'm going to use this method right now. There are several methods I can use to solve this problem, and this is the method that I have introduced to the world. I'm going to use it right now. So basically this problem, since we are using the Gaussian-Dolo elimination, we come to our solution. On our solution, what we are going to do, we are going to get an augmented matrix from this particular problem that have been given us, because Gaussian elimination deals with matrices and the same as the Gaussian-Dolo elimination. So we are going to have an augmented matrix. What do we mean by that? It means we are only going to deal with the coefficient of the variable, with respect to position, and the constant as well. So writing our augmented matrix, we're going to have 5 minus 4 in the first row with a constant 6. We also have the second row, minus 3, positive 3, minus 3 to be a constant. Like I said, we are using the coefficient of x and y plus and also the constant term. So your goal in using Gaussian-Dolo elimination, like the same as Gaussian elimination, Gaussian Jordan, common root first and second order, is to get capture the coefficients of the variables and the constant. So this is the augmented matrix we are going to use. To find a number that we can multiply by 5 there, positive 5, and the result added to -3 will give us 0. So we're going to say the number we multiply by the first row plus the second row will give us the result of the second row. Now, here is it. That number will be 305 times this first row, arrow 1, plus the second row, arrow 2, will give us the result of the second row, arrow 2. So let's indicate it. So this will be, we got 5, -4, we got 6, the constant, then we got -3, we got -3, positive 3, and -3. So it means that this minus this 5, 3 over 5, we're going to just place it here, 3 over 5, such that when we multiply 3 over 5 by 5, we're going to have positive 3. Minus 3 will give us 0. So we have done with this. We now go to our next step. Our next step, what we're going to do now is this number we have gotten 3 over 5, we're going to multiply it by the first row to get the value and add it to the second row to get our value. So we say here 3 over 5 times 5 will give us positive 3. Positive 3 minus 3 will give us 0 here. Then we say 3 over 5 here, we have done with this term already. We come to the next term. So we say 3 over 5 times -4. You're going to have -12 over 5. Now, here is it. Let me do common arithmetic. 3 over 5 times -4. We're going to have -12 over 5. Then we add it to this value. Plus 3. Dividing this by 1. This is a common fraction. So the least common denominator will be 5. So we are at -12 plus 15. So finally our answer will be 3 over 5. That means -12 plus 15 will give us positive 3 over 5. So in here we're going to have positive 3 over 5. We will draw that one out. Then we say it again, 3 over 5 times positive 6. So we say 3 over 5 times positive 6 will give us 18 over 5, and we subtract -3 to it. So we say -3. It's the same as plus -3 because negative times positive is negative. So we're going to say about this by 1. The least common denominator is 5. So we cross multiply. That means 5 going to 5 one time times 18 will give us 18. 1 times 18 is 18 minus 1 going to 5. 5 times 3 minus 3 will give us 15. So finally, we're going to still have the same t over 5. So it means that at the position of the constant here will be 3 over 5. We close it, and you just skillfully bring down the first row of 5, -4, and positive 6. We have already done this, so to go to our next step, what we're going to do is we look at this. We have already gotten our 0 here, So the next thing is to get positive 1 here, such that this will be the values of y. This will be the coefficient of y. That means 1 times y will give us y, and the answer that will be here will just be the values of y. So what is the number that we can multiply by 3 over 5 to get a positive 1? That number is just the inverse 3 over 5, or just say the reciprocal 5 over 3. So here we're going to say 5 over 3 times our 2 times the second row must be able to give us the same second row. So we indicate this here. So just carefully bring down the 5 over 2 here, because it's only going to be multiplied by the second row to just give us the second row. We are already done with this. So our next step is to multiply 5 over 3 by the second row to give us the second row. So let's keep it going. Here we have 5 over 3 times 0 will give us 0. 5 over 3 times 3 over 5 will just give us 1, because this is the reciprocal, give us positive 1. Give it out 1. And the same 5 over 3 times 3 over 5 also give us positive 1. So close it. You just bring down the second row. So it's 5, -4, and positive 6. Now, here is the key. Most mathematicians in several math books that I have studied over time will only stop at this level, because the first value here represents x, the second value will represent y, and this is the answer for y, the values of y. So most mathematicians will just stop here, say y equal 1, and go back to use one of the equations here to solve for x. This is the first variable. That which mathematician call back substitution. So like the question say here, we should use the Gaussian elimination without back substitution. So since it is from here that I created a means to see how this I can continue to use the matrix and get our answer. So it is from this point that the surface of the first surface of my knee came to be Dolo. That's why I call it the Gaussian-Dolo Elimination. Because from this level now, we're going to stay use matrices until we get our answer. We are not going to use back substitution. No back substitution. So let's keep it up. Now, what would be the number that we can multiply by 1 to give that when we subtract 4 from it to get 0? So we say that number will be positive 4. So we say positive 4 times arrow 2, that means multiply by the second row, added to the first row, arrow 1 will give us the first row. So the arrow is very short, and we just indicate it back here. Now we can just carefully put a full back here to indicate that we're going to multiply the second row by 4 added to the first row. Definitely, it is at this point that we're going to now multiply the 4 here by the second row. So we come to our next step. We skillfully draw our metric sum. So we say 4 times 0 is 0. 0 plus 5, we will just have our positive 5. 4 times 1 will give us positive 4. When we subtract negative 4 from the values positive 4, we will have 0 at this point. Skillfully draw our line, and then we say 4 times positive 1 will give us positive 4 plus 6 will give us 10. We can now skillfully write down the second row. 0, 1, 1. We now close it. We have already gotten our 0 at this point. So our next concern is to get 1 here, so that we're going to have 1, 0, 0, 1. Such that S here will be 0, 0, this will just be the values of y. You got 1 time y will give us y, this will be the values of y. And as we have 1 here, the values of y will be 0, so we will just have x to be equal to the constant that we're going to find finally. So we ask ourselves, which number can be multiplied by 5 here to give us positive 1? That number is just the inverse of 5. So finally we say the inverse of 5 is 1 over 5 times the first row. The first row here must just be equal to the same first row. So finally we just place our 1 over 5 at this point, because we're going to multiply by the first row to give us the first row. We can now say here 1 over 5 times 5. We come to our next step, so skillfully employed. 1 over 5 times positive 5 will just give us positive 1 at this point. 1 over 5 times 0, just give us 0. Skillfully draw our hand. 1 over 5 times 10 will just give us 2, because 1 times 10 is 10. 10 divided by 5 will give us positive 2 at this point. Skillfully close it. We just bring down the second row to be 0, 1, 1. After we are done today with this, we can now see here, we draw our bars. So we're going to say multiply the first row, multiply them by x and y. That is 1 times x, we close it. And the second value, 0 times y, we close it. Will give us the constant 2, close this. Let's work similarly to this. 0 times x, close it. 1 times y, close this, and we get a constant here to be 1. When you're done with this, it's very simple now to understand. We draw our metric sign again. We say 1 times x will just give us x. 0 times y will give you 0. 0 times x will just give you 0. 1 time y will give you y. Skillfully draw it. 2, 1. Finally, at this point now, we get to our final conclusion by getting our answer, which is very simple to understand, and we really enjoy using the Gaussian-Dolo elimination. So finally, we got 0 and 0 here. It doesn't make any significant sense to us, so we say we got x at this point, we got y at this point. Just draw your line. We got 2, we got 1. Finally, we say therefore the solution surface is parenthesis open, x is 2 and y is just 1. So thank you, we have already done. This is our answer. The values for x in this system of equation in 2 variable problem is 2 and y is less than equal to 1. So I hope you will enjoy using the Gaussian-Dolo elimination. It is a new method, a method that will help you out, that will enable you to use the Gaussian elimination, to use Gaussian elimination without bias substituting and getting your answer. Very easy, and don't forget, any comment, please comment on my YouTube channel, because I believe that your comment will help me to add more future, will help us to do more research and add more future that will help to improve your mathematics skills. And don't also get twisted, kindly like, subscribe to my YouTube channel. The more you subscribe, the more we develop a lot of methods that will help to make your mathematics strength very efficient. And I also want to say a special thanks to my director, in person of Mr. Winston Yango, who is always standing by me. He has done extremely well. It's a great pleasure to say thank you. I got you on mine, and also to my mathematics consultant, Tokpah. These are people that have really been getting me on track and moving on to the level that we are in. This is not where we're going to stop. We're going to keep it up, giving you the best you deserve so as to make your math stream more efficient. Kindly subscribe, like, and share my video. Thank you. Have a God bless us day.